here it is the properties of nickel based. Here is a nickel based. Okay, properties of nickel based superalloys. The first one is a high temperature strength. What does it mean? It means they retain their mechanical strength even at the temperature above the 1000 degrees C. Okay, so if we reach above the 1000 degrees C, still they can retain, they can behave as a, what they are having a mechanical property. So they don't lose their mechanical properties until they reach even reaching at a 1000 degrees C. So this is a very good advantage of being these alloys in practical life. Okay, so used in jet engine. Why we are using in a jet engine? Because in this kind of engines that we have a very high temperatures, and at that particular temperature we must have the material that can sustain their properties. Okay, otherwise they will lose their properties, and our component will fail, and due to that we would not have any condition to use that particular component in an efficient way. Okay, so better to have a temperature, high temperature strength means they can sustain their mechanical properties up to that particular temperature, and this is sufficient as at 1000 degrees C. Okay, so that's why it's a jet engine gas turbine where the material must withstand extreme heat, because in these whatever the engines that we are having, okay, in practical life, all have a very high temperature during their working conditions. Okay, so the material that has been used for that particular engine must be of high temperature resistant. Okay, otherwise I would our material will get, our component will get fail, and there would be no use of application of that particular component in particular systems. Okay, now the creep and fatigue resistance. So excellent resistance to the creep deformations. What is creep means? The slow permanent deformation under the stress at a high temperature. So we have discussed in details in last class what is a fatigue failure. Okay, and due to when fatigue failure arises, then the material must have the resistance to that particular fatigue resistance, or that kind of loading is known as fatigue resistance. If we talk about the creep means the slow permanent deformation. When the deformation is a permanent, it means they are above the yielding strength, because after the yielding strength that material cannot retain their shape and size when they are having an applied load. Okay, so but what happens at a very high temperature? The creep means the normal deformation is normal deformation. Okay, so whenever the stress is more than yielding, it would be having a permanent deformation. But permanent deformation, along with that, we have the high temperature, then it is known as a creep. Okay, so normal deformation means the deformation that is going to be induced by applying a load, okay, on any materials. But when it is being held at a very high temperature, then such a deformation is known as the creep. Okay, so it is also kind of the deformation, but it is a kind of the deformation at a very high temperature or elevated temperature. Third one is the high fatigue strength, preventing the failure under the cyclic load. We have discussed in last class and yesterday that what is the fatigue strength and what is the fatigue failure, and why this kind of the failure occurs. It occurs generally due to the cyclic load or dynamic load, and during in practical life we all, whatever the component that we are having, they all are experiencing a fatigue failure, because we all have the dynamic loading, okay, during the component applications. Okay, the third one is the oxidation and corrosion resistance. Okay, so high chromium and aluminum content enhance the oxidation resistance. It means if we are having the chromium, I hope that you are able to recall when we were in the first unit that I already know that the incorporation of the chromium in any alloy, any metal, that increases the corrosion resistance. Why? Because they have a resistance to oxidation, and the corrosion phenomena occurs due to oxidations, right? If we talk about the normal environment, if we talk about the seawater, these are the also the kind of the oxidation, but that oxidation occurs due to the water. Okay, but in our environment, normal environment that we live in, that is due to the oxygen which is present in the air molecules, and that we know 21% of in air by volume fraction, oxygen is present in air, right? And rest all are in a maximum quantity that we are having nitrogen, and few percentage are of other elements as well. Okay, so incorporation of the chromium and ammonium content enhance the oxidation resistance, right? There is a productive oxide layer prevent the material degradation in the harsh environment. Harsh environment with productive oxide layers prevent the material degradation. Degradation means it prevents from having corroded. means the corrosion will occur due to the oxide layer that is being formed on the surface of the material. Okay, so it doesn't matter what the kind of the harsh environment that we are having, but we cannot, go. We cannot have our material fail due to the corrosion. So why the corrosion will, stop because of the oxide layer which is going to be, formed on the surface of such kind of a materials. Okay. Now talk about the phase stability at a high temperature. So maintains a stable phase center cubic structure. So what the kind of the structure that we are having a FCC. Know what is the FCC? FCC means the phase centered cubic structure. It means you are having one of half atoms at each faces and 1/8 part of the atom is at each corner. Okay, so total, if we count how many atoms are present in FCC, then total number of atoms are 4 in FCC, right? So it has the structure even under the prolonged so being the stress okay, for long structure which is the face centered cubic structure. Okay, so they don't get generally what happens if a material has a, any kind of a structures when you heat for the long time of a when you heat up to a certain temperature, then it gets changed their phase change means does what does mean either it can change their crystal structure or it can change their material sense means solid liquid gas. Okay, so they all called as a phase change. Okay, so at a high temperature and being heat exposure means what at high temperature heat means they are taking the energy in the form of heat, which means they are taking they're raising their temperatures. Still they don't get change their you know uh, uh, structure at a stress as well. So being a prolonged time for the high stress and a high temperature, i- such kind of the material don't get change their phases. Okay, it sustains their crystal structure, which is FCC. Okay, now we talk about the precipitation hardening capacity, right? Okay, so now we are here to precipitation and hardening capacity. What is the hardening capacity? So strengthened by the gamma dash. Okay, gamma dash means gamma prime. This is known as also gamma dash. Phase precipitation, which improves the mechanical properties and prevent the grain boundary sliding. Grain boundary, what is it? I mean, when the material gets solidified, different kind of the boundary like this. I hope that you are able to. So here, different grain, different grain, right? So, and these are the boundaries, grain boundaries, right? Okay. So it prevents the grain boundary sliding. When it slides, then there is basically when they are not too much strong in itself, then it will slide when we apply the load. So it prevents. Okay, good weldability and fabrications. So weldability means the material that we are talking about are having a good welding, capacity. Okay, it can be welded very easily. Fabrication means we can fabricate a different kind of component very easily. Okay, so some nickel based super alloys are designed for the ease of welding and machining. Okay, however, due to their strength, certain grades require the specialized manufacturing techniques like vacuum melting and powder metallurgy. Why it is required? Because due to the high strength, so in such kind of a metal alloy, we get at a high strength. And due to high strength, sometimes we are not able to manufacturing or we are not able to machining the very easily. So we need some specialized manufacturing techniques like the vacuum melting. So here we are not melting due to the temperature difference. Okay, we are melting due to the vacuum. Okay, so we are basically decreasing the pressure. Vacuum means what? We are decreasing pressure. As we know that we will increase the pressure, then we need more and more heat to melt a material. Okay. Once if you are an opposite of that, if you will decrease the pressure, then material will get melt easily. Right. Suppose that we know that boiling point of water is 100 degrees C. But what it is true? No, it is wrong. Better to say the boiling point of water is 100 degrees C at a 1 atmospheric pressure. If you increase the pressure or if you decrease the pressure, the melting point will also decrease or increase accordingly. Suppose if you have increased your pressure, okay, whatever the when we boil the water, so what the pressure it is experiencing there is the atmospheric pressure. So once you increase the atmospheric pressure, you must not be getting your water boiled at 100 degrees C. Why? Because you have increased the pressure. Now you need a more heat, okay, to melt or to change their phase of water. Okay, so you must be having more than 100 degrees C to change the phases of water. Okay, so what does it mean? It means that you can decrease the pressure, okay, to melt the material. So just vice versa, if pressure is high, then you need more heat, okay, and if you reduce the temperature, then you would be having less heat required to melt the material. So for a particular material, that we have a provision that if we reduce the pressure up to a certain limit, then it will get automatically melted. Okay, this is a provision. Okay, sometimes what happen if you have the liquid form, okay, and then you are increasing the increasing pressure, then you will get a solid forms. Okay, suppose you have the gases, if you increase the pressure, increasing the pressure will converted that gases into the solid. So just suppose it, if you have a liquid and if you are reducing the pressure, then your liquid will convert into what? Liquid will convert into gases. So similar to that, if you have a solid, then if you are reducing the pressure, then it will convert into liquid. So melt. Okay, so either you can provide the heat at a certain constant pressure, okay, or you can keep the temperature constant, and reducing the pressure will also melt your material. So in that case, you need to change you need to fix your temperature as well. So whatever the kind of the process that you take, you must have to be careful about keeping one thing at least constant. Either you can keep the constant pressure, or either you can keep temperature constant. So what we call a boiling point of water is 100 degrees C. In this process, we keep a pressure constant. Okay, but here what we are going, the vacuum melting means we will keep the temperature constant, what is the atmospheric temperature. Now we will decrease the pressure. So up to for the different materials, that would be the different parameters, different points of that particular pressure at which the material will get start melting to the liquid. Okay, I hope now you're clear about that. What is vacuum melting and polymetry? Polymetry means, I mean, we are able to make the materials or make the alloys with the help of the powder metallurgy. Powder means where the all the components would be in the powder form, and then we mix together to get a different kind of alloys.